What's up, on Power Ask Group? Today on the onboard compressor project, we're doing electrical. Let's go. Okay, before we get started on the actual build out of the electrical, let's talk about the components we're going to be using and just touch on a few little details. This is my representation of a compressor. I know my drawing is not all that. This is the representation of your pressure switch. This is a toggle switch. This is your fuse. And this is what I would call a battery in the drawing. So yeah, go with that. Many of you out there are going to know that this little symbol right here, these lines, represents chassis ground. A chassis ground is where your negative cable on your battery goes to your engine block, and it also goes to your frame someplace. That provides the negative side of your battery connection to throughout the whole chassis of your vehicle, be it Jeep, truck, car, whatever the case it may be. That is what is considered chassis ground. Your negative cable from your battery goes to your engine block and to your frame and so on. Now your positive connections coming from your compressor, this right here is the clutch. Whenever you add power to this wire right here, what's going to happen, it clamps that clutch closed. Instead of this right here, this clutch freewheeling with your belt turning and all that, it clamps shut and allows the pistons inside here to turn. So you bring that wire coming from your clutch over to your pressure switch. Now your pressure switch, they have a variety of them, okay? Different pressures meaning. You can go low, you can go high, whatever. Now I cannot confirm this because I've never tested. Supposedly these compressors can run up to 300 psi. I don't know that. If you know that and you've tested that, drop it down in the comments. Let me know because I'm really curious. But like I said, I've never pushed it high enough to find out. So the pressure switch that I installed in my Jeep turns on at 95 and turns off at 125 psi, pounds pressure. So what happens when the air pressure reaches 95 pounds, it says, yo, I need some more air. It clamps shut inside here, kicks power to the compressor kicks on, it starts pumping air to the rest of the system, builds it back up to 125. When it gets to 125, this pressure switch says, okay, whoa, pressure 125, we're good, cut it off. This switch opens back up, cutting power, which opens the clutch, allowing the belt to freewheel again. So that's how that works. Now you need to turn it on, correct? Of course you do. That's where your toggle switch comes into play right here. So when you flip that switch on, it completes the circuit, allows the pressure switch to do its job. It turns on the pressure, turns on the compressor at 95 psi, turns it off at 125, and we're going to talk more about that here in a moment, but just for demonstration of the circuit, we're just stick with my numbers at the moment. My numbers meaning that's what my pressure switch does. So now, of course, you want to protect your circuit, so you got a fuse in line here. I'm actually shooting this part right here after I installed all my goodies. So I can tell you that fuse right there needs to be about a 5 amp. Because the compressor, when I put the little circuit tester on it, it only kicked off about 3.3 amps or something like that. So you can get a 5 amp fuse in the circuit and you're good to go. So you'll come through your switch. It'll connect here, come back out here. The wire goes through your fuse. One of these, or whatever you decide to use, totally up to you. I've got a battery drawn here for simplicity of explaining how a circuit works, or how this circuit works. What you actually want is this all tied to a circuit that is turned, whenever you turn your key on in the run position, your engine running, that is when you want all this right here to have power, okay? Why? Well, let's just say if you had a minuscule tiny leak, okay? And that leak will eventually bleed down till you hit that low side. In my case, the on is 95 psi. If I had a small leak and I forgot to turn off my switch and I've got it wired directly to a battery, what's going to happen? If you said it's going to turn on the compressor, you're correct. Because once the pressure, the air pressure within inside the system drops to 95 or lower, this pressure switch clamps shut, therefore completing the circuit and clamping the compressor, or clamping the clutch on the compressor. Well, I mean, the engine's not turning. One, you're not making pressure from the compressor. Two, your alternator's not running, so you've got a parasitic drag on your battery at that point. So that is why you want to wire this whole thing up to a circuit somewhere that is only on when you have your key in run position. Besides that, I mean, really, you don't want your compressor. What's the point in having the compressor if your engine's not running, you know? So there's that. So that's what you really want to do coming off here. Like I said, I just drew the battery for simplicity's sake of explaining the circuit. Now, I said earlier that we're going to touch on that pressure switch a little bit more, and here's what I wanted to add to that. They make different sizes of pressure switches, meaning my particular build runs 95 on, off of 125, and you can get it to run much higher pressures if you want to. You get switches to run much higher pressures. I don't see the need in that. 125 is more than adequate to run your small air tools that you may need, more than adequate to blow up tires, because your tires are running. Okay, if you run up to recommended pressures that you see on the sidewalls, you don't look at 35 to 45 psi. Of course, if you've got your tire pressure set correctly, more than likely you're not running that much pressure. Now, to get a pressure switch to run up to say 200 pounds or so, okay, what is that going to do for you? It's just going to add more strain to all your air connections. Where your hoses connect to your compressor, where your hoses connect to your manifolds and to your tanks and to your air fittings that you do your quick connects and stuff. All those, each one of those places could be a potential air leak. So the higher pressure you have, the more likely you're going to have leaks and stuff. And also, it's going to make a compressor work a lot harder. Shutting off at 125 versus shutting off at 200, it's how much pressure is being put on those pistons. So you can actually increase the life of your compressor by running it no more than you have to. Meaning if you stop at 125 versus 200, it's not going to run quite as long. It's going to catch up with this air faster, if it makes any sense. So again, real quickly, the compressor bolts to your engine block, which gets its ground wire from the compressor, or from the clutch actually, comes right here, goes into the pressure switch, out of the pressure switch to your toggle switch, out of the toggle switch to your fuse, out of the fuse to a powered source with key on. Then of course the battery comes out and goes back to ground here, and which therefore completes the circuit. I'm doing this after I've already done all my install. There's one thing that I changed. This is how a typical circuit set up. Your fuse goes between your power source and your switch that does the whole circuit. The way I've got mine set up, the fuse is actually between the pressure switch and the main switch here. Why? It just happened to, it just really worked out better that way, because as you'll see in the build, that the wire that came from my switch, and I'm using a fancy switch in my Jeep, and you'll see that in the video, that it added because of the wire that was coming off that switch, it stopped right there at the pressure switch. So that little bit of added length of putting this in place actually worked out real well for me. So instead of my fuse being between switch and power source, my fuse is actually between switch to pressure switch. So let's get on with the build. So the electrical is actually pretty well straight up simple. This right here is the wire coming off of the clutch on the compressor, and it's going to jump over to here, to this post here. This post here is going to go inside the Jeep. Your ground actually comes from being bolted to the engine block, so that's what completes the circuit. Inside the Jeep, I've got a switch set up. Let's go check it out. I've actually had this switch configuration set up for a long time. I hit this switch right here, which arms both of these switches. This right here gives both of these switches power. This right here, I push to start. You know, if I push it, it kicks the starter over. This right here, as you see, says air compressor. I've had this on there for a long time. Onboard air has been a project I've been meaning to do forever, and I finally just got my tailing gear to do it. So I'll turn that on, and that should kick on my compressor. Yeah. And if you guys noticed on my last video, I asked, hey, where can I find me some covers for my little air fittings? Right there, right there. And of course I got one on the back, and I just knocked my cover off down there. But here's what I ended up getting: vinyl leg tips, and they are 7/8 inch size. Some of my subscribers chimed in and said, hey, you know, try this, try that. And somebody said something about furniture covers or furniture feet or something like that. It dawned on me that my Ace Hardware across town has little covers and stuff like that. Lowe's and some of the other hardware stores I had here in town did not have them, and so I ran over to Ace Hardware, and guess what? They fit perfect. And you see that one, as I pointed out, that one right there, and of course we go back here, and I need to put my other fitter on one of these days, and there's my other cover. Does just perfect. This switch right here comes with this pretty little plastic cap right here. Let's use that as a protective cover while we're at it. You see, I've got two female spade connectors already pushed onto the terminals. Put this back on, right like that. And you see right through the top, you can see right there's one and there's one. So if you feel froggy, you can take yourself a Sharpie marker and put a little dot there and a little dot there indicating where the wires are going to come up through. But what I'm going to do is use my drill, hover right above it, and lightly that marked that one. It marks that one. Then I'm going to pull it off and finish drilling them all through, just enough to clear my wire going through and some heat shrink tubing. Now I've got one of the female spades heat shrinked in place, going through the cap, and I got the other one right here ready to heat shrink. But before we get all froggy with everything, let's test it. I'm going to take the other end here and touch it to the battery post, the positive post. Listen. See what I'm doing here to test. Just touch the positive battery post. Like I said, this is getting the battery, plus your ground comes directly off the body here where it's bolted to the engine. So when you touch the positive battery post, you can hear the clutch engage. Now let me look. Right now, I can free spin it and get free spin. Watch that clutch move when I hit it. See it move just a little bit. Stick it outside the battery and hold it. So now I can turn this, it turns the whole front. That's turning the pistons inside the compressor. Now I pull the wire loose from the battery post, it releases the clutch and free spins. And notice how I've got the terminals heat shrinked. I pulled it down over the connector a bit to give it a little bit more protection. You can pull it all the way down toward the end, totally up to you. But now I'm going to pull these through the cap and I'll put them in place. I got my connectors plugged up. Take your cover and just push a little bit. You push it up through the holes that you drilled and move it down, boom, and you have a protective cover over top of it for water protection and anything dropping, shorten it out. So now that we got that all set up, I need to run the wire inside the cab to my switch, and I'll also be putting in inline fuse to help protect the circuit in case something goes wrong, it shorts out or something. These little pigtails right here only cost $3-5 or something like that. I forget what I paid for this because it was in the middle of a bunch of junk I had in my shop. It comes with a 30 amp fuse. That is way too much. So how much do I need? I don't know yet. So what happened, once I get all this wired in, I activate it, then I'll measure my current to see how much amp draw the compressor has, and that'll tell me what size fuse I need. Cool? Cool. Now I'm going to figure out how to run this through all that to make it all nice, neat, and tidy. And right there is where I'll be running it through to go to my switch. So things got changed up just a little bit. I was running that yellow wire back up through there. I'm like, there's just too much crap in the way. Meaning there is all that had to come back out. That was like wiring for other lights I put in. Say for instance, you know, that one of my front bumper, I just don't run it anymore. So I took out all the wiring for that and some other miscellaneous junk that was in there. So I cut it all out. So I was about to pull a wire through there, and it was like a gray wire. I'm like, okay, what does this go to before I cut it out? Because it was out here just deadhead, meaning it was just hanging out here all by itself. And I traced it, and it was all bundled up in a wad. I'm like, wait a minute. Then I traced it back. It was going to my compressor switch. Whenever I originally put this compressor switch in, I had already pre-wired my air compressor and ran the wire outside. I forgot about it. I had the wire bundle tied up underneath here out of the way, so whenever I finally got around to my air compressor, all I had to do is pull the wire out there, hook it up, and was good to go. I found that I did not have to pull all this out. And I realized it's going to freak some people out. Why? Because I didn't show it hooking to the switch. And because I didn't show me hooking that wire to the back of the switch, that's going to blow some people's minds. Because, oh my gosh, I skipped a step. No, not necessarily. Refer back to the beginning of the video where I drew out a diagram showing the wire coming from the compressor to the pressure switch. Pressure switch goes through the fuse. Then from the fuse it's going to go to your rocker switch or toggle switch or whatever it is you decide to use. And then that goes to a hot wire underneath your dash someplace. You just need to find a keyed hot, not an all-time hot, not a full-time hot, a keyed hot, which will be on your fuse block someplace. And I've got a video showing how to find that. And I'll link those up down there where you guys can check it out. And then the body of the compressor itself completes the circuit for the ground. Again, I'll link up the video showing how to find a keyed hot and showing how to wire that little switch panel together. Okay, cool. Now back to my original point. I kind of went squirrel there for a moment. So when I found that gray wire, I ran it back over through here, and I realized, hey, wait a minute, I don't need that yellow wire no more, and I need to put a fuse in. So it just turned out to be about the right length. That gray wire by itself was just going to be a little too short to reach this, but I still had to put the fuse link in. So I redid this part right here. I can plug that into here now. Let's try to get that right because I'll show you behind the installation. There it is. Heat shrink it down. Make sure it locks on good. Yep, we're good. And this right here pushes down like that. Locks down over top, so that protects that circuit. And then this right here's all. This is just nothing more than crimp connectors and heat shrink. That's all it is. Crimp connector and heat shrink. And what I'll do is I'll take, get my wire loom, which I had a piece right here somewhere. What I do with it. I found it. So I'll run this right here to about right there, and run that all down to there, and tuck that inside my harness back in through there, and make it all nice, neat, pretty. I need another piece for come across that, but anyway, y'all get the point. But the question is, does it now work? All right, spin the clutch, spin the clutch. It's free spinning. All right, now let's go turn the switch on. So what we do is we'll power the switches up, air compressor, we'll get right here and watch the middle plate. See? We have air compressor. Yay! Now the next thing I do is take that belt off and put my air conditioning belt on. Got my wire zip tied back. I think this right here, I'm just going to give it another piece of wire and redo the connector here and drop it under the compressor and bring it up, because I don't like that hanging out on top of the compressor. I mean, it's just me being picky, but I'd really rather have it under, but it was long enough at the time. It made the video, but you get the point. Zip tie quiz time. Y'all are like, what? Why is there a quiz about zip ties? Well, there's actually a very good question. You can get zip ties in many different colors. You can get them white, black, red, blue, whatever you want, color you want, which can be handy for doing, color coding harnesses and stuff like that. But when it all comes down to it, which is the stronger zip tie of the bunch, which zip tie actually lasts longer in the sun, heat, all that stuff, there's one particular color of zip tie that lasts the longest. I'm pausing, let you guys think about it. If you said black zip ties last longer, you would be absolutely correct. Black zip ties, because of the plastic they're made of, actually will last a lot longer out in the sun, withstanding heat and stuff like that. I heard you're asking why are you using white zip ties? Well, actually it's for a particular purpose. For a project I'm working on my drawing table in the house, and they were in the Jeep and I grabbed them. That particular purpose for these zip ties is because I'm going to be holding wires down on boards to do electrical e-course. I'm working on a course to teach, so you guys can learn how to do 12-volt electrical work. And when that course is released, I will let you know. So now let's test the circuit to see how many amps it takes to activate the compressor. You see I've got the compressor turned on. And I plugged that contraption in, which leads around to this contraption. 3.3 amps is what it takes to engage that compressor. So you can pretty much run a 5 amp fuse and be good to go on this. And if you guys want one of these little tools that is like super crazy handy, I'll drop a link down in the comments so you guys can pick one up. All you do is simply pull the fuse out. You see right here it's got a couple of connectors. You see I got no amp draw right there. Plug it in. And you see right there 3.3 amps. That's a handy little tool. Okay, my Power Addicts crew, I hope that little electrical setup for the onboard air was easy enough for you to understand. It's not very hard. The current flow is basically going to come off your battery, through the fuse, through the arming switch or the turn it on switch, whatever. Then it's going to come through your air pressure switch into the compressor. The compressor is grounded. The ground completes the circuit. It's a pretty straight up simple circuit. So don't overcomplicate it. And like that fancy switch I got going on, you don't need that. Just simply take you a regular on-off toggle switch or a rocker switch or something like that. Will be completely fine for that setup, okay? So don't overcomplicate it. So if you guys enjoyed that video, hit me with a thumbs up. Subscribe if you haven't. Leave me some cool comments down below. Appreciate you hanging out. Peace. Later, y'all. Look right there. Obviously not a Jeep intake, 302 intake. Upcoming project. Boy, I tell you what, my head is glowing out here. So 302 intake, upcoming project, not a Jeep. So if you guys got any idea. So anyway, peace out. Later, y'all.